Welcome to the video tutorials of the book Methods, Evaluation and Research in Education by Mohammad Aktaruzzaman. And today we're going to learn how to do trend analysis in SPSS. The value of a variable may increase or decrease with respect to time. Trend analysis can judge whether the variable value may increase or decrease in a particular time or period. For example, the price of a product may increase or decrease in a particular season. Thus, decision can be taken about a variable after considering a number of periods. Time is a considerable factor in case of trend analysis. Let's go through an example. A psychologist wants to know whether the reaction time of a human being increases or decreases with respect to the increase of age. He conducted a research on 25 people of different ages. The age groups are 15 to 20, 35 to 40, 55 to 60, and 75 to 80. The data are kept in the file Trend Analysis. The null hypothesis may be formulated as there is no change of reaction time with respect to the change of age. Considering this scenario, now we're going to test the null hypothesis. Let's see the SPSS data editor window at the screen. Now go to the File menu, then open Data and then Data File under SPSS Evaluation folder and open the file Trend Analysis in the SPSS data editor. The file is shown in SPSS editor in the data view. Let's see the variable view of the data. There are two variables, age and RT, which is reaction time, which are of numeric type, and the scales of measurement are ordinal and scale respectively. In the values column, age variable, which is in fact the age group, is defined as 1.00 for 15 to 20, 2.00 for 35 to 40, 3.00 for 55 to 60, and 4.00 for 75 to 80. Now, let's go back to the data view of the SPSS data editor. You see the variables at the top of each column and also see the reaction time of 100 individuals of different age groups. The pattern of data view is different from the usual one. You can change the data view pattern by clicking the value labels icon, which is third from the right at the toolbar just below the menu bar. Now, go to the Analyze menu, then Compare Means, then One-Way ANOVA. Now, take the reaction time in the dependent list and age group in the factor field. By clicking the Post Hoc button, specify the significance level and select 2 key if homogeneity of variances exists and Games-Howell test if homogeneity of variances do not exist to see which groups are causing the mean difference if null hypothesis is rejected. Now click Continue. Also click the Options button and select Descriptive and Homogeneity of Variance Test. Click Continue and then press OK. See the output at the screen. The mean and standard deviation of reaction time for different age categories are shown in the table Descriptive, and in the table Test of Homogeneity of Variances, the sig value is 0.488. Let's see the most important table, ANOVA. In this table, the sig value is 0.013. For testing the hypothesis, SPSS needs only the sig value to be compared with 0.05. In SPSS interpretation, sig value greater than 0.05 means acceptance of the null hypothesis, and on the other hand, sig value less than 0.05 means rejection of the null hypothesis. The details of it are described in chapter 10 of the book. In case of homogeneity of variance test, sig value 0.488 is greater than 0.05, which implies that the null hypothesis, which is there is no difference between variances of the groups, is not rejected. It implies that the variances are approximately equal. In case of ANOVA table, the sig value 0.013 is less than 0.05, which implies the null hypothesis is rejected, which means the research hypothesis is accepted. So, there are changes of reaction time with respect to the change of age, and this effect cannot be attributed to chance factor. Let's check out the table post hoc test multiple comparison at the output viewer. As in case of ANOVA table, the null hypothesis is rejected. That means there are changes of reaction time with respect to the change of age. But this result does not tell us which age groups are responsible for the effect, which is the mean difference actually. So, we need the post hoc test results to verify this. The post hoc test depends on the homogeneity of variances. As the variances are approximately equal, the two-key test can be interpreted. If the homogeneity of variances do not exist, Ames-Howell test can be interpreted. It is observed in the two-key test results that the age group 15 to 20 and 75 to 80 are causing the mean difference by counting the number of asterisks, which denotes the mean difference between the two age groups is significant. Hope you have learned trend analysis to some extent. Thank you for staying with us. It's Yazdani saying you goodbye.